Hello everyone, this is Chandrakant Mishra. Today I am going to discuss the two-port network of network theory. Before going to the topics, I want to say something about your gate preparations. Hopefully you are doing great in your preparations. You must be making your synoptic or short notes so that you can revise during the last hour of the preparation. And you are practicing a lot of examples, previous year questions, so that you are adapted with the gate pattern and problem solving aptitude. Let's begin. Two-port networks, as name suggests, it has two ports. So let's designate this is a network. You have port 1 here and this is your port 2. So I'll designate the conventional voltage reference as the V1 and current flowing into the network taken as positive I1, and similarly the voltage at the second port V2 and current flowing into the network as the I2. So this is the convention, so you need to know it. So there are basically there are four type of networks parameters for the two-port network. One is the G parameters or open circuit impedance parameters. What are these parameters? We completely characterize the network, two-port networks, by its network parameters. So there are four type of network parameters: open circuit, impedance parameters or G parameters. Second one is the short circuit admittance parameters or Y parameter. Third one is the transmission parameter or ABCD parameter. Fourth one is the hybrid parameter or H parameter. Hybrid or H parameter. So for this, the third point, we have inverse of it, that is the inverse transmission parameter or A dash, B dash, C dash, D dash parameters. For serial number 4, we have inverse hybrid parameters or G parameter. Okay, so we'll discuss one by one. Please pay attention. So first case, we'll discuss the open circuit impedance parameter. G parameter. So here the set of equations are V1 equal to G11 I1 plus G12 I2, V2 equal to G21 I1 plus G22 I2, or in matrix form I can write as V equal to G I. So V is a column matrix, that is V1 V2, then G is a 2 into 2 square matrix, G12, G21, G22, and I again a column matrix, that is I1, I2. Okay, so equivalent circuit equivalent you can write like this. Just think of you are applying a current source and measuring the voltage. So obviously it will act as a dependent voltage source. So this is your G11, then G12, I2, and you applied a current source here, I1, and this is your V1. You just apply KVL here, and you will find V1 is equal to Z11 I2 plus Z12 I2 plus Z11 I1, and this side this is G1 to 1 and G22, and this is your G21 and I1, and the current source is your I2, and this is your V2, right? So how you calculate all the G parameters? So remember, if I have been given the G matrix of a network, this one, that is all parameters of network. For time being, just I want to characterize the network. That means if G matrix or G parameter of a network has been given, I can completely characterize that network. That means I need not to require anything more when the measuring the input impedance, output impedance, all these things, when it is connected to a network or circuit. So your G11 is defined as V1 upon I1 upon when output or port 2 is open. This is no rocket science. You just see here equation here. When I make I2 0, how you can make a current I2 equal to 0? Simply by making port 2 open. Similarly, when I1 0, you can calculate the Z12. That means how you can make I1 0? Just simply making open circuit make the open circuit of port 1. So alternatively, you make open circuit of one port, measure the associated parameters. Similarly, make open the other port, then associated parameter. In this way, you can find out the 4 parameters which completely characterize or describe the given network. So Z12 is equal to V1 upon I2 when I1 equal to 0. Z21, you can use the Z or G, as more appropriate is G is a shortened form, so you can use it. So V2 upon I1 when I2 equal to 0, and G22 is equal to V2 upon I2 when I1 0. You can clearly see that for when we make port 2 open circuit, I can get Z11 and G21. Similarly, making port 1 open circuit, I can get G12 and G22. Let us move to an example to clarify more. Consider the network. It's a popular T network, and this is your 0.5 Siemens, and then this is your point 0.2 Siemens, and this is your 0.4 Siemens. So we need to find G parameter. As usual, by definition, see, very simple. Every time you will find 1 to 2 question in your GATE exam, one 1 mark question and one 2 mark question. So G11 is equal to V1 upon I1. You see, when I2 0, there is no current flows through this two Siemens resistors. So before that you should convert into the ohm, otherwise you will be confused. Okay, so it is 2 ohm, this is your 5 ohm, and this is your 2.5 ohm. So no current flows, so you can easily write when I2 equal to 0, which implies V1 is equal to 2 plus 2.5 I1, because I2 equal to 0. So G11 is equal to V1 upon I1, which is 4.5 ohm, right? So already we have made the output open, so we can simultaneously calculate the second parameters, which is Z G21, which is your V2 upon I1, V2 upon I1 when I2 equal to 0. See, what will be the V2, because I2 0, so no current flows through the 5 ohm resistor, so V2 is only reflected here whatever the voltage drop at 2.5 ohm resistors. So V2 is equal to 2.5 I1. So G21 is equal to V2 upon I1, which is 2.5 ohm. Now come to the G12, which is V1 upon I2 when I1 equal to 0. Just want to show you when I1 equal to 0, so there will be no current flowing through, because this is open circuit this side, so no current flows through the 2 ohm resistors. So you can easily see that your whatever the current flows through the 2.5 ohm resistors, so that is equal to the your V1, so 2.5, and you have already connected a current source of I2, that is your I2. So G12 is equal to V1 upon I2, which is 2.5 ohm, right? And then come to the G22, which is defined as V2 upon I2 when I1 equal to 0. So clearly you see here that is V2 equal to current flowing through the 5 ohm resistor and same current flowing through the 2.5 ohm resistor, because this side is open, no current flows. So your V2 is equal to 5 plus 2.5 I2. So G22 is equal to V2 upon I2, which is 7.5 ohm. So collecting all the parameters in the matrix form. Okay, so G11 4.5. Okay, G11 is the 4.5, G22 is the 7.5, and this is your 2.5 and 2.5. Later on we'll see that we needed to calculate all the parameters, because when we learn the property, we'll see that when the all the passive networks are symmetrical, right? all the passive networks are symmetrical. So symmetrical network we will later on see when the network is symmetrical, G12 equal to G21. So you can use the property, you can smartly use the property to find the other parameters. Okay, so this is the case for the G parameters or open circuit parameters. Now we will discuss the short circuit parameters or Y parameters. Y parameters is defined as I1 is equal to Y11 V1 plus Y12 V2, and I2 is equal to Y21 V1 plus Y22 V2, or in the matrix form I1 I2 is equal to, this is a set of linear equation type, so Y11 Y12 Y21 Y22 and V1 upon V1 and V2, right? So same way you can define here the forcing function is your V1 and V2, and we measure the current. So equivalent circuit you can write like this. This is your V1, okay, and obviously there will be a current source, dependent current source, and a admittance, because V1 upon Y11, so Y11, and this is the dependent current source is the Y12 V2, and this is your I1, and in a similar fashion you can write this side also Y22 and a dependent current source V2, and this is your I2, and this is your Y21 V1. So this is the, just apply a KVL here, I mean a KCL here. I1 is equal to Y11 V2 plus this voltage V1 into Y11. So how the parameters are defined, just look at the equations here, and you short circuit one port and calculate two parameters, and short circuit other port and calculate other two parameters. So when I short circuit, output V2 equal to 0. When I short circuit here, that means this will be short circuited, V2 equal to 0, that means Y11 is equal to I1 upon V1, and Y21 is equal to I2 upon V1. Similarly, short circuit the port 2, I mean port 1, that is V1 equal to 0. So when I make V1 equal to 0, Y12 is equal to I1 upon V2, okay, and Y22 is equal to Y2 upon V2. Let us work out one example. So find Y parameter of this network. So as per the definition, how to make the short for port 2, like make V2 equal to 0. So when I make the V2 equal to 0, what happens? My circuit reduced to, because this terminal same, so no current flows through the 4 resistors. So 5 ohm and this okay, the circuit is like this, plus V1, this is a V1 and I1. So as per the definition, so you can see that okay, your V I mean to say I1 is equal to V1 upon 5 plus V1 upon 2. Okay, so I1 upon V1, which is Y11, is equal to I1 upon V1, that is 1 upon 5 plus 1 upon 2, so 10 upon 7 upon 10, right? Next one is the when output is sorted, that is your, or port 2 is sorted, that is Y21, which is I2 upon V1 when V2 equal to 0. So we have already made V2. So this is your I2. See the convention. Now the question arises here, because we have sorted. Let's say you have already this element here, but it doesn't make any changes. This is the direction of your I2. Understand this. So you can, if you know the simple Ohm's law, you can say that minus I2 is for this circuit, minus I2 is equal to V1 upon 2. Whatever the voltage and the current, that is the actual current will flow in this direction, but as per the convention, our I2 flows into the, so that's why I have included a negative sign, and this current will be the V1 upon 2. So I2 upon V1 is equal to minus half, which is, this is your Y21, which is minus 0.5 Siemens. All these are unit chair Siemens, like 0.7 Siemens. Okay, now we'll move to the input side. So as usual, this is your 5 ohm, 2 ohm, and this is your 4, right? This is a 4 ohm, right? V2, this is your I2, and you have sorted the input here, or port 1. So this is obviously your, as per the convention, I1. Okay, this is your I1, and no current flow. This current will be 0, obviously, when the potential difference between the 2 points is 0. So no current flows through this 5 ohm resistors. So what are the parameters we need to calculate? Y12 by definition, this is your I1 upon V2 when V1 equal to 0. Already we have set the V1 equal to 0. So just look at this circuit, how I1 is here calculated. So similar case, I1 is this current, this is the potential difference between the 2 ohm resistor is the V2, and here the current will be the, because current will be flowing in this direction, but actual convention is the this direction. So minus I1 is equal to V2 upon 2, which implies, so I1 upon V2 is equal to minus 0.5 Siemens. This is your Y12. Next is your Y22, which is I2 upon V2 when V1 equal to 0. Already we have set Now look at this, how you can calculate the I2 upon V2. So you can easily say that I2 is equal to this current and this current. So I2 will be the V2 upon 4 plus V2 upon 2, right? That means 4 upon 3 V2. Okay, V2. So I2 upon V2, which is your Y22, which is equal to 3 by 4, that is 0.75 Siemens. So finally we can collect all the parameters, in the matrix form. I can write Y11 was your 0.7 minus 0.5 minus 0.5, 0.75 Siemens. This is your Y matrix. Hope you have paid attention with the how I calculated these parameters. Once you know these parameters, you can easily characterize the networks. Next we'll move to the transmission line parameters, or simply transmission parameters, or ABCD parameters. So here is all the quantity are in the input side. So V1 is equal to A V2 minus B I2, and I1 is equal to C V2 minus D I2. This minus sign is due to the, not due to the parameters, but due to the current flowing in the opposite to the conventional directions. Remember only this difference for the ABCD and A dash B dash C dash. This is V1, this is your I1, V2, I2. So here in the ABCD parameters we take current in this direction, so it will be minus I2. Suppose this is the 3 ampere current. If I ask this is the conventional current flowing in the left side direction of the left is the 3 ampere, and I same ampere, the value of same current, if I say that it is in the right side, so it is a minus. Just you put the minus 3 ampere, minus sign into that, magnitude remains same. Just I am confronting with the convention. Actual current is 3 ampere. If I am indicating direction in towards the right, so it will be the simply minus 3 ampere. Same way, if my convention says that it is I2, so obviously if I take out of this terminal opposite to this, so obviously minus I2. So due to that only this negative sign arises. So in the matrix form, V1 I1 is equal to A B C D, and C here it is V2 minus I2. Okay, because current I will be taking in this the minus I2 directions. So how they are defined? Same way, like make I2 0, that is I2 0 means what? Make port 2 open. When I make I2 0, that means port 2 open. So A equal to V1 upon V2 when I2 equal to 0. That is open circuit reverse voltage gain. Open circuit reverse voltage gain. Then come to the already we have made a output open, so your C will be coming I1 upon V2 when I2 0. Similarly, open circuit reverse admittance, open circuit reverse transfer admittance, because it is not the same port. Whenever you are calculating the quantity in the same port, we called in the same port, like I1 upon V1 or like that, we call the admittance. But here as the one quantity from port 1, another quantity from port 2, so we call it transfer. And why reverse? Because we are not calculating the I2 upon V1. Whenever the I2 upon V1 or V2 upon I1 or V2 upon V1, that is first in the numerator, if the first quantity comes from the port 2, then we call the forward. See, first there are two cases. One is the forward. Forward means first quantity in the numerator should be from port 2. Okay, that is, and forward. And if the that is the this is the forward quantity, and if numerator has the quantity from port 1, okay, this is called the reverse quantity. And where to use the transfer, that is the impedance and transfer impedance. Transfer means when you are referring the two different port, that's why I call the transfer. Here the transfer admittance, here you see reverse transfer admittance. You need to go just check that you are dividing the dividing I1 with the V2, I1 from the port 1, so as per the this it cannot be forward, so it is a reverse. Then it is not on the same port, so it is a transfer. And obviously this is a current and the voltage, obviously admittance. Then then B equal to V1 minus I2 when V2 equal to 0. V2 0 means short circuit. Okay, here the open circuit, it is a short circuit. What is this? Short circuit. So short circuit reverse transfer impedance. And D, that is your I1 upon minus I2 when V2 equal to 0. Short circuit, obviously reverse current gain. Current gain is defined as minus I2 upon I1. Normal current gain we don't normally we normally drop forward, so you can say the forward current gain. So by convention, current gain means forward current gain. Okay, so it is a, because the first quantity is of port 1, so it is a short circuit, because V2 equal to 0, short circuit reverse current gain I1 upon minus I2. So these are the 4 elements of the ABCD parameters. Now we'll move to the example. By everything, theory is to understand, or everything depends upon your understanding with the example, because ultimately you will be calculating all these things in your competitive exam, especially GATE, and also a lot of questions come in the engineering service exam also. Find the ABCD parameters for the circuit. All are in ohm. So your A is equal to V1 upon V2 when I2 0, when I2 equal to 0, so you simply have a potential division here, that is voltage across 5 ohm resistor is your V2. So V2 equal to 5 upon 5 plus 1 V1. So A is equal to V1 upon V2. That means, so V1 upon V2 is the 6 upon 5. C equal to I1 upon V2 when I2 equal to 0. So I1 upon V2, very simple, that is your V2 is equal to 5 I1. So C equal to I1 upon V2, which is 1 upon 5. That is your, it will be Siemens. Okay. So same way, see, when I make the I2 0, that means no current flow. So simply the potential drop across 5 ohm resistor is your V2, and the current flowing is I1. Now come to the that is open. This is the open circuit case. Now we will do the short circuit case. That is your V2 equal to 0. So B equal to V1 upon minus I2 when V2 equal to 0. V2 0 means you need to sort it. That means you sort it. And this is your I2, V2 0. So see, so this is your V1, and we need to find out the I2. So you can, if you see here, V1 is equal to V1 equal to V1 equal to 5 into I1 plus I2, but we need to relate the I2 I1, that is your I2, yeah, I2 with I1. So uh, 5 I1 plus I2, and 1 is the I1, 1 I1, right? So it will be 6 I1 plus 5 I2. By writing a equation here, we have 5 I1 plus I2 plus 2 I2 equal to 0. Five I1 plus 7 I2 equal to 0. So I1 is equal to minus 7 upon 5 I2. Putting these values in the above equation, so V1 is equal to 6 into minus 7 by 5 I2 plus 5 I2. I2 minus 42 plus 25 I2 is equal to how much it is? 25 5 30, then 40 17 minus 17 upon 5 I2 So your what we are calculating, b equal to v1 upon i2, which is equal minus 17.5 ohm. Actually by definition b equal to v1 minus i2 na. That is your 17 upon 5 ohm. Now next is your d equal to i1 upon minus i2, v2 equal to 0. See this equation, okay, this equation. So i1 upon minus i2 is just 7 by 5, so d is equal to 7 by 5. So ultimately, so transmission parameters of this network is the 6 by 5 17 by 5 by 5, 1 by 5, 7 by 5, 1 by 5 and 7 by 5. Okay, so next we'll discuss inverse transmission parameters. Popularly known as A dash, B dash, C dash, D dash. Okay, by now you must have guessed what could be the equation. In ABCD parameters, we are relating output parameters, that is voltage and current, with the input parameter, that is voltage current. Here input parameters are that is related with the output parameter or port 2, like V2 equal to A dash, okay, V1 minus B dash I1, and I2 is equal to C dash V1 minus D dash I1, or V2 I2 is equal to A dash B dash C dash D dash V1 I1 minus. Okay, let us move to the hybrid parameters or H parameters. H parameters relate V1 is equal to H11 I1 plus H12 V2, and I2 is equal to H21 I1 plus H22 V2. That means one port is short circuited, that is when you make V2 equal to 0, that is output shorted, you find H11 and H21, and when input is open circuit, for this case I1 is 0, that means input is open circuit, then you get the other two parameters like H12 and H21. So H11 by definition V1 upon I1 when V2 equal to 0. V2 0 means that is your output is short circuited. So it is called the short circuited input impedance. H12 V1 upon V2 when I1 0. I1 0 means open circuited reverse voltage gain. Then come to the H21, which is I2 upon I1. I2 upon I1 when V2 equal to 0, that is short circuited negative of the current gain. Negative of current gain. See, current gain is always like this, minus I2 upon I1, because current gain by notation is calculated. This is your RL, this current, because we have assumed by convention this is the I2, so this current will be minus I2, okay, and input current already I1, so minus I2 upon I1, but here I2 upon I1, so that's why short circuited negative of current gain. Then H22, which is I2 upon V2 when I1 equal to 0, open circuited output admittance. My handwriting is bad, but I am speaking clearly so you can understand. So equivalent circuit looks like this. This is your H11, this is your H12 V2, and this is your V1, and this is your I1, right? And I2 equal to V2 H22, so this is your H22 and H21, this is your H21 and I1. Okay, so these parameters have extensively used in modeling of transistors. That part will be covered in the analog electronics. So you should understand these concepts so that it will be helpful to understand the understand it in the analog electronics. So so it is very clear, H22. So you can easily apply the here KCL and here KVL to find the two basic equation of the this H parameters. So what do you see here? We do open circuit I1 0, so that means driving function here is a current and driving function is your voltage. Okay, so we do the short circuit for port 2 and open circuit for port 1. So we'll discuss an example so that you will be you can have a more understanding of this H parameter calculation. Consider this circuit. Four ohm, 2 ohm, 2 ohm. Okay, so first we will calculate the H11. H11 by definition V1 upon I1 when V2 0. So V20 means short circuited. Okay, right? So when I do a short circuit here, the 2 ohm and 2 ohms are parallel. So V1 equal to 2 parallel 2 into I1 plus 4 I1, that is 5 I1. So H11 is equal to V1 upon I1 is equal to 5 ohm, right? Now H21, which is I2 upon I1 when V2 equal to 0. So here you can put a current division, because current I1 is coming, so one part is going here, another part is going here. As you can see that whatever the current, it will be split equally. Otherwise you can use the general relations for I2 minus I2 is equal to 2 upon 2 plus 2 I1, which implies H21, which is I2 upon I1. Okay, that is your 0.5. Now open circuit the input side. Two and what is that? 5, right? Yeah, 4. Okay, this side we have made open. This is your V1 and this is your I1. As we have made the port 1 open, no I1 will be 0. So H12, which is V1 upon V2 when I1 equal to 0. You can see potential division here. V1 is equal to 2 upon 2 plus 2 V2, which is 1 upon 2 V2. So H12 is equal to V1 upon V2, which is 1 upon half, is 0.5. Yeah, here is a correction, H22, because here we have missed the minus sign. Okay, right? Can you see here this portion? Minus I2 upon 2 plus 2 upon 2 plus 2 I1, which is H22 equal to H22 equal to I2 upon I1, so minus 0.5. Okay, now come to the H22, which is equal to I2 upon V2 when I1 equal to 0. So I2 upon V2 is open. So V2 is equal to 2 plus 2 I2. So I2 upon V2 is equal to 1 upon 4 Siemens. Okay, so which is your H22. So finally we have H matrix, that is 1 upon 4, then H12, which is 0.5, then minus 0.5, then H11 was your 5 ohm. This is your Siemens, and the 0.5 and minus 0.5 are unitless, because ratio of voltage or ratio of current. Same way we can define the inverse G parameter, inverse H parameter, or call the G parameter, small g parameters like so. Here see, it's very easy to understand this. Here the for H parameter case, V1 I2 H11 H12 H21 H22 I1 V2, right? For inverse G parameter, sorry, inverse H parameter or G parameter is the I1 V2. I1 V2, whatever the are the output case, that will be G11, G12, G21, G22 and V1 I2. Input current and output voltage. So I1 is equal to G11 V1 plus G12 I2. V2 is equal to G21 V1 plus G22 I2. Those H parameter, you see here G11 is calculated by open circuit of output. There H11 was calculated short circuiting the output like V2. Similarly, G12 is calculated by short circuiting the input. So that's why it is called the, or otherwise you call the whatever the parameter, the output parameter is related to the input parameter in inverse H parameter. Like G11 is equal to I1 upon V1 when I2 equal to 0. That is open circuited at output. So what other parameter at open circuited output? That is your G21, which is V2 upon V1 when I2 equal to 0. Similarly, G12 is equal to I1 upon I2 when V1 equal to 0. That is short circuiting input. And G22 is equal to V2 upon I2 when V1 equal to 0. That is short circuiting the input. You will get the GT2. GT2 to V2 upon I2, that is the output impedance. Short circuited output impedance. So these are the basic definition or conceptual things, how the parameters, different parameters are conventionally defined and representations with examples. So in the next class we will discuss about the interrelationship between the different network parameters and how to, what are the properties of symmetrical properties, how the H parameters are related, and reciprocal property, how H parameters are related, then series connection, cascaded connection, parallel connection, series parallel connection, parallel series connection, what are the parameters are added in all these combination, or what are the parameters are convenient for the cascading, when the two networks are cascaded to each other, what parameter we should use. All things will be discussed in the part 2 of the two-port network. Also we will discuss the, in another part we will discuss the, if time permits, in the same part 2 we will discuss the some of the gate question, or in the third part we can have the lot of gate question discussion at the depth. See you in the next class. Till then, keep learning. Take care. Bye.